All right, for this problem, we are being asked to find the volume of the solid, this blue solid right here. This problem has two components, dy and dx. This is the inner component with respect to dy, and the outer component with respect to dx. Okay, so first we must integrate the inner, and then we could do the outer. But let's first explain this. There's these three parts. Let's explain what these boundaries mean. The distance from 1 to 3. If you look at here in the diagram, we have the distance from 1 to 3 with respect to y. And then right here we have the distance from 0 to 7 and the distance from 0 to 7 with respect to x. So what about the height? Well, the height is given to us by right here, the 9 on the z-axis, right? So if we multiply the length and the width and the height, we get the volume of the blue shape. All right, let's start integrating. So for the inner integral, this part, we have 9. We integrate the 9, just add the x. Actually, the y. We're integrating with respect to y. All right. So put our boundaries. Now we're going to compute them. We find the difference between the boundaries. And we have 18. All right, that's the first part, that's the inner part. So now we're going to integrate with respect to dx, okay? We have 7 and 0 at the bottom. All right, so with respect to dx, okay, we're doing the outer part. And this guy, we just put it right there, okay? All right, so the integral for 18 is 18x. Our boundaries, let's compute them, find the difference. All right, 18 times 7 is 126. Therefore, the volume is 126 units cubed for this shape. All right, that's it. Right here we're given the double integral with the boundaries from 0 to 3, 0 to 1, 2 times x times y, integrate with respect to dx and dy. So we're going to start with the inner, which is this part, and we're going to integrate with respect to x, okay? And we're just going to split them up. All right. There we go, with respect to dx, okay? So let's just review a little bit. Remember that the rule to integrate m to some power, you just add a 1 and use the same number in the denominator. So here we're going to do it. Okay. So remember, we're integrating with respect to x. So x to the first power plus 1 is 2. put the 2 on the bottom. Okay. And if you notice, the 2 just cancels out. And don't forget our y. We cannot leave our y behind. Okay. So we end up with x to the second times y. And now we can compute our boundaries, which is 1 to the second power minus 0 to the second power times y. But that will just give us 0. So we just got to compute the boundary with the 1. 1. This will just give us 1. 1 times y is y. Okay. So this is our part of the answer for the inner integral. All right, let's do the second integral right here separately. And this one is from 0 to 3. Okay. And our y, we just bring it up here. Okay. All right. And now we're going to do this with respect to dx, I mean dy. Okay. We already did dx. Now we're going to do it for dy. All right. So remember, we have y, and the rule is to add 1. So y to the first power plus 1 is 2 all over 2. Right? We bring the 2 down. There's our boundaries. So let's compute them. All right. And we don't do the 0. We don't have to, because 0 to the second power divided by 2 is just 0. So we just have to compute the 3. And that's just going to give us 9 to the second power. Okay, right here we have to do this double integral. And this time I'm going to do them together. And I'm just going to use this giant square bracket to do the inner integral. Okay. And I'm going to rewrite the square root as an exponent. So the square root of u as an exponent is u to the 1/2. And dx is going to be x to the 1/2 also. Okay. And we're going to do the inner part, so it's with respect to du first. Okay. So u to the 1/2 integrated, it will be u to the 1/2 plus 1, which is 3 to the second. And that will go in the bottom. And we just simplify this and we will get 2 to the third. Okay. And let's break down the x to the 1/2. It's going to be from 4 to 9. Okay. So as you can see, I'm just working inside the big brackets for the inner integral. Okay. So let's write down the 9, 3 to the second power, all over 3, x times 1/2, right? And now we're going to do our lower boundary. Okay. So when we simplified this huge term by the second term, you should get 38 . Okay. And as you can see, x to the 1/2, I rewrote it back with the square root. Okay. Everything else simplifies to 38 over 3. Right? Now we're going to work on this next integral, which is now the other part. This part right here. Okay. So okay. The fraction 38 over 3, I'm going to bring it to the front. And I'm just going to bring the boundary right here, 4 to 9, 4 to 9. And when I bring this to the front, I'm left with the square root of x. It's going to rewrite it as an exponent. It's just so much easier. Okay. Okay. X to the 1/2 plus 1 is x 3 to the second. Remember, we bring it to the denominator. When you simplify this, you get 2 over 3. Here is our boundaries. Okay. All right. So let's compute our boundaries now. Okay. Minus the lower boundary. That should be a 2. Okay. When you simplify this on a calculator, the inside part, and you multiply it by 38 over 3, you should get 1,444 over 9. This is just basic arithmetic. Okay, that's your answer. Okay, right here we have a double integral, slightly more complicated. Okay, we're gonna integrate the inner part, okay, with respect to dx. And we're going to rewrite the denominator. We're going to do some u substitution. So we're going to substitute everything inside the square root with u. Okay. So u equals to x plus y squared. Okay. And since we are doing some u substitution, we could find our new limits of integration. So the upper limit is going to be equal to the upper limit for dx is 9. So we're going to replace the x for 9 and keep the rest. The lower limit for x is 4. So we're going to replace the x with 4. We end up with 4 plus y squared. Okay. And I'm going to rewrite this. Plus y squared. And I'm also going to rewrite the denominator as an exponent. 3 times y times u to the negative 1/2 power. Because the square root of u as an exponent is u to the 1/2 power. And since it is in the denominator, it's negative. That's why it's negative. Okay. So we're integrating now with respect to du. Okay. So we could bring, what we can also, to simplify even more, we can bring the 3 times y to the front. And we're just going to integrate with respect to u. Right. That will give us u to the positive 1/2. Because negative 1/2 plus 1 is 1/2. All divided by 1/2, which is just equal to 2 times u to the 1/2 power. Okay. We could simplify a little bit more. 3 times 2 is 6y. Okay. U to the 1/2 power. And let's write our limits of integration. All right. Now let's substitute our values. Since this is a 1/2 power, we could just write it back with the square root. All right, distribute the 6 times y. Okay, so our new integral is going to be this whole thing down here. We're going to have to now we're going to have to integrate all of this. just going to rewrite this here. And this whole thing will be our new integral. And now we're going to integrate with respect to dy. Okay. Our limits of integration for dy were from 0 to 2. Okay. This 6, we could factor it out. And we're going to end up with 2. Just erase this parentheses here. Okay, 9 plus y squared. Oh, remember that? I factor out the 6. Okay. So what we can do here is find the difference of two integrals, which means we're just going to split these two integrals in half and solve each one of them. Okay, let's distribute this 6 again. And we're going to integrate with respect to dy. All right. So I'm going to integrate this first one right here. Okay. And then we're going to rewrite this. And we're going to do some v substitution. I already used u in the last one. So we're going to integrate with respect to dv. Okay. All right, so v is going to be equal to everything inside the square root, which is 9 plus y squared. Okay. And we're going to have to find the derivative of y, which is equal to y, right? And then we're going to solve for dy. And we're left with 2y. Okay. We could find the new limits of integration. Let's find the upper limit. Okay. So the upper is 2 to the second power, and we're going to get 13. Let's find the lower limit. All right, which is 0 to the second power, just 9. Okay. So I'm going to rewrite this with the new limits. And we have y, and I'm going to rewrite the v as an exponent times v to the 1/2 power times this right here. So right here we have a 1/2, and notice what just happened here. We have a y in the numerator and a y in the denominator. We can just cancel that. And we're left with 1/2 right here. And we could just bring the 1/2 to the front. And 6 times 1/2 is 3. Okay. And let's rewrite this to make it more clean. Okay. And let's integrate the v. Well, not yet. Let's just rewrite it here. All right, let's make some space. So we have v 3/2 all divided by 3/2, which is 2/3. Okay. We could simplify this even further. Cancel out the 3. Okay. And we're left with 2v 3/2. Okay. So let's substitute our values in. All right. And this should give you 26 square root 13 minus 54. Okay. So now we're going to integrate the second integral, okay, which is this guy right here. All right. And we're going to do the same thing. We're going to do some w substitution since you already use v and u. We're going to integrate with respect to dw. And w is equal to everything inside the root. Okay. Let's find the derivative of y, which is 2y. Let's solve for dy. Okay. Let's find our new limits of integration. Okay. Okay. The upper limit here is 2. So this is just going to give you 8 for the upper limit. Let's do the lower. That should just give you 2, obviously. Okay. All right. Let's rewrite this. The w as an exponent. Okay. I'm going to multiply by that. There's a 1/2 right there. And also the y. And again, we have a y in the numerator and a y in the denominator. And they just cancel out. Okay. And again, we could just bring the 1/2 to the outside. 6 times 1/2 is 3. Okay. Let's just clean this a little bit. And let's bring our new limits of integration. Okay. Okay, w to the 1/2 power plus 1 is 3 over 2 divided by 3 over 2 is the same thing as 2 over 3. Could simplify that even more. All right, let's substitute our new limits of integration. And we're left with, that should give you 32 square root 2 minus 16. Okay. And I'm just going to rewrite the integral that we had before, the two integrals, the difference of two integrals. Okay. All right. And the answer for the second one goes right there. And here's our other one. Let's bring down this negative right here. And then you have to distribute this negative. Okay. And you should end up with 26 square root 13 minus 32 over 2, 38. And that's your answer. final answer. Okay, right here we have to evaluate the double integral over the area R, okay? And right here are the limits, okay? So right there and right there, okay? So let's integrate with respect to x, okay? To x, all right. Okay, so we have e to the 4x plus 4y, okay? And then our limits are 0 to natural log 5. So we're going to do a u substitution for our exponent. All right. All right. So we substituted 4x plus 4y with u. So u equals 4x plus 4y. And let's find the derivative of x. So du. All right. Now let's solve for dx. And this is going to be equal to du over 4 dx. Okay. So now that we're doing this, let's find the boundaries. Okay. New boundaries. Let's find the upper first. So we have u equals 4x plus 4y. All right. So let's substitute for x. So x is natural log 5 plus 4y. Equals, well, all right. So we found our upper limit. Now let's find the lower limit. All right. Let's substitute for x, and the x is this. So is this 0 right here? For the upper, right here, this x, we substitute it with natural log 5. For the lower is 0. And we're doing it only for the x because we are integrating with respect to x. Okay, so we found our lower limit. Then we're going to put them right here. Okay. Plus 4y. So that's the upper limit. Now the lower limit. Okay. So our du since we were integrating with respect to dx, right? So our du, we're going to put it right there. Okay. All right, let's move down the page a little bit more. Okay. So the integral of e to the u is e to the u. And since we have 1/4, we could bring it to the outside, but we could just multiply right now since the integral is itself. So e to the u times 1/4. It's like if I had bringing it right there. Okay. All right. Okay, let's put our limits. So u is this. And now we subtract. And we put our lower limit. The next one. And when we solve this, you should get 156 e to the fourth y. Okay. So now this whole thing was with respect to dx. Now let's integrate with respect to y. So whatever we got here, we're going to use it down here to integrate with respect to y. Okay. And here's our limits for y. From 1 to natural log 4. Okay, we could factor out this 156. And right here, we're going to do, I'm going to use V as in Victor to do V substitution. Okay. So that means that our V is equal to 4y. Because we substituted for 4y. All right, let's find the derivative of 4y to find du. I mean dv. That would be 4d dy. And let's solve for dy. All right, let's find our boundaries, our new limits of integration. All right, let's find the upper. So we already know that v equals 4y. Let's substitute the y with natural log 4. All right. So we found the upper. That's at L. Okay, let's find the lower. And the lower is pretty easy. One. So it's 4. Okay. And remember this is with respect to dy. So our dy is dv over 4. So we're going to bring it over. Okay. So the integral of e to the v is itself, okay, times 156 times 1/4 or divided by 4, right? We could simplify, you don't have to, only if you want to. We could still do the arithmetic like that. Okay. When we simplify this, it's going to simplify to 39e to our first limit of integration, which is that. All right. Minus 39e to the 4th. And we get you should get 9,984 minus 39 e to the fourth. So that's our final answer.